So this part of our chemistry class is something that's very difficult to wrap our heads around, but we're going to be doing it the entire year. So hopefully, as we continue to practice this throughout the entire year, it'll get a little bit easier. And I don't just make these rules up off the top of my head. They are rules that are used across the entire continent dealing with scientific numbers. Okay? So significant figures is how we round. Significant figures include all digits that are known in a measurement plus an estimated last digit. The reason why these are significant is because we know for a fact that we have 50.0 grams of something. We know that for a fact it's not 49.9, and we know that we don't have 50.1. So that estimated last digit is the next digit place that we can estimate and what things are going to be. So these rules, I'm not going to talk about them now because we're going to go through them and how do we identify all these rules within numbers. So the first rule, all non-zero digits are significant. So when I say non-zero, I mean anything that's a 1 through 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? If it's a 0, it doesn't count. And we're looking at the overall number and what's there. Okay? So for our first one, we have 825. There's 3 numbers that are not zeros there, so we have 3 significant figures. I sometimes put SF for significant figure. 66, 2 numbers, not zeros, that's 2 significant figures. 19,395, no zeros, they're all significant, 5 sig figs. And last but not least, we have scientific notation, 2.1 times 10 to the 6th. If you look at everything in front of the times 10 part, that tells you what you look at for the significant figure. So there it's just 2 sig figs. So anything, if it's not a 0, it counts. Next rule. Zeros between non-zero digits are significant. So if they're trapped, so maybe put trapped as your keyword there. So if they're trapped, then you know that they're going to count because that 0 is closed in around it, okay? So 505. There's a 0. It's trapped between the 2 5s. So that's going to be 3 significant figures. The entire thing counts. 7,005. There's 2 zeros, but they're trapped between the 7 and the 5. So we're going to say that that is 4 significant figures. 10,208. 2 zeros are there. They're not adjacent, but they are still trapped between all the numbers. So that would be a total of 5 significant figures. And then throw in some more scientific notation. 6.075 times 10 to the negative 5th. Again, don't look at the times 10. Just look at what's before. There's 4 significant figures for that number. So if they're sandwiched, if they're trapped in, it counts. Next, zeros in front of the non-zero digits are not significant. They are placeholders. Any 0 that can be gotten rid of by scientific notation are not significant when, a little sidebar, when if you're looking at the number, it's on the left of the non-zero digits, okay? So that's important when it's on the left. So we have 0.03. There's nothing to the left of these zeros, so they're all the way to the left. That means they don't count. So our only significant figure is the 3. So we have 1 sig fig there. 0.008, same rule applies. Those zeros don't count, so we're just left with the 8. So that's 1 sig fig. 0.000025. The zeros don't have anything trapping them in, so it's just the 2 5, so that is 2 sig figs. And last but not least, 0.000000407. Throwing in 2 rules here. The zeros in front don't count, but that last 0 is sandwiched in between the 4 and the 7, so it is counting. So that is 3 sig figs. So if it's a small decimal and there's nothing, not a digit that's sandwiching it in, they're not going to count. That's a hard one for people. Another difficult one for people is when you do have a decimal point on the page, zeros at the end of the number and to the right of that decimal point are significant. 73.00 means that we know for a fact we have 73.00. We don't have 72.99, and we don't have 73.01. It's exactly that. So that would be 4 sig figs. .050. Well, the first 0 is sandwich, so that's going to count. And the second 0 is at the end, and it's after other things that count, and it's after decimal place, so that still counts. It's 4 sig figs. 9.000. It's after the decimal place. It's to the right of the decimal. So all 3 of those zeros count to make it a total of 4. And then our last one, we have 2.010 times 10 to the negative 4. Don't look at that times 10 to the negative 4, remember? Just what's in front. This is a trapped 0. That's after the decimal point 0. So that is 4 significant figures. Last rule. This is when you don't have a decimal place. Okay? They're on the right side. But so a key would be no decimal on page. So anything to the end of the number and to the left of the decimal point are not significant. So really, you look at this rule when there isn't a decimal point on the page. You have to imagine that decimal point. Okay? So the first one, we have 800. There's no decimal point. We imagine there's a decimal point. So that means these 2 zeros in the front don't count. So that's only 1 sig fig. 3,920. We have to imagine the decimal point, so that 0 doesn't count, and that is only 3 sig figs. 30,720. We have a sandwich 0. It's trapped, so that does count. But the one on the end does not, so that is 4 sig figs. And then last but not least, we have 50, and that 0 doesn't count, so that's a 1 sig figure. Okay, so yes, it's really easy once you get the hang of just identifying significant figures, but we don't leave it things at easy in chemistry class. We like to make things difficult. So now we're going to learn how to add and subtract, multiply, and divide with these rules. The first rule is adding and subtracting. Adding and subtracting is not looking at the entire number like we just did. Adding and subtracting looks for decimal places because we need the least precise measurement. So that means we are looking at the least amount of decimal places. And I'm going to put DP on this part for decimal places because I'm lazy and don't want to write it out. So least precise measurement means we're looking for the least amount of decimal places. Okay? We're not going to solve this equation because we've got examples. Okay? So, for example 5, the first one we have, we are adding. So let's go ahead and just do the math, like we would in math class. Add all of the numbers together and see what we get. So 3 centimeters plus 4.90 centimeters plus 2.3 is equal to 10.2. And the unit, the label, is going to just be centimeters, just like it was before the equation sign. Okay? Well, now that we get our answer, we have to round it according to decimal places. So remember, DP equals decimal places. So we look at each part of our equation to tell us which one's the lowest amount of decimal places. Okay? Well, we have 3 centimeters. There's no decimal point on that page. So there are 0 decimal places. 4.90. We've got 2 numbers after the decimal, so that means we have 2 decimal places. And 2.3, we have 1 digit after the decimal place, so that would be a 1 decimal place number. The lowest amount is what we need to round to. Well, the lowest amount of decimal places we have is 0 decimal places. So that means that I need to round my number to have 0 decimal places. I can only have things greater than the decimal place. So I'm going to round and cut off my number right at the decimal. So my final answer, we don't need that 2 anymore, is going to be 10 centimeters. like when you box your answers, please. All right, next one. We're subtracting. 506.30 milliliters minus 30.08 milliliters. When you subtract those two numbers, you get 476.22 milliliters. Okay? Well, let's look at our decimal places in the problem. The first number, we have 2 decimal places on that number. And 30.08, we have 2 decimal places as well. So, hey, I think we're going to be rounding to 2 decimal places here. So, look at that. Our answer already has 2 decimal places. So, we are all good. Last but not least, let's add those together. When you add the 3 numbers together, you get, in total, 3.23372 seconds. All right. First number, we've got 1, 2, 3, 4, 5 decimal places. Second, 2 decimal places. And third, 4 decimal places. Well, our lowest number of decimal places is 2. So in this one, we're going to round after the decimal place because we need to include 2 of them. So I'm going to cut off my number between the second and third decimal place. So then I only include what's the left, right? But I do need to look over and see if I need to round up, which I forgot to mention up above. If we have a 3 next door, it's not going to make it round up. Regular rounding rules apply. If it's 5 or greater, round up. 4 or below, leave it the same. So our final answer is going to be 3.23 seconds. So that's how you add and subtract. You look at the decimal places, okay? Just what's after the decimal place. When you're multiplying and dividing, which we'll do this more often in chemistry, we'll multiply and divide more often, we look at the whole number. We're looking at the least number of significant figures. So I would put a note that says, look at whole number. You could put add the whole number if you wanted to. Look at the whole number. So this is like what we were going through when we were learning the rules of significant figures, okay? In addition to having to round our numbers at the end, we also need to change the units, just like you do in math class. When you multiply units, you have to add the exponents together. So like maybe centimeters times centimeters equals centimeters squared, because it's a 1 implied and a 1 implied. So you would pick 1 plus 1 equals centimeters 2, okay? When dividing, you subtract them. So on this one, it would be 1 minus 1 if we were subtracting. So then that would be centimeters to the 0, which technically means you don't need a unit. But if you include that, that's okay. All right, so let's practice these. First one we have is 10.04 kilometers times 4.5 kilometers. Well, when you multiply those two together, you should get 45.18. And our unit, we have 1 kilometers to the first, kilometers to the first. We're multiplying, so we add those together. So it's going to be kilometers squared. Then we need to look at the whole number that make up each part to see what we round to. So this whole number, we have trapped zeros. So that means we have 1, 2, 3, 4 sig figs. So I'm putting SF to know that I'm looking at the entire number versus 4.5, no zeros there. So we just have 2 significant figures. So I need to round to the least amount, just like we did before. So I'm going to round to 2 significant figures. Mess myself up there. So this time I start at the left, where my first significant digit starts, and I count 1, 2, and I cut off. So I am stopping to make this a whole number this time, but that's because of my significant figure rule, not because of decimal places, okay? And I look next door, hey, I just keep it the same, so my final answer is 45 kilometers squared. All right, and the next one, 60.4 meters cubed divided by 20.59 meters squared. When you divide those out, you should get 2.93346 our unit, we have cubed minus squared, so that makes 3 minus 2 equals 1, right? So we just have meters left over. Looking at our whole number, we have a trapped 0, so that means that this is 3 significant figures, versus 20.59 still has a trapped 0, but that would be 4 sig figs. So, lower 1, round to 3, starting before the 2, and cutting off after the second digit in the decimal places. So, looking next door, keep it the same, don't round up, 2.93 meters. So, we are going to practice these. We're going to use these the rest of the year. We have significant figure practice to work on now.